Hello everyone and welcome to a new Sega Mega Drive and Genesis game dev tutorial. In this video I'm going to teach you how to add these semi-solid platforms, the type you can jump up through but catches you on the way down as you're seeing here. I think that the majority of platform games have this kind of special collision tile, so I think it's a good thing to add to our little demo. In 16 tile I'm going to alter our level map and add these column tiles here to represent this kind of semi-solid platform. And the end result is going to look something like this, so it's a little playground that we can test our code in. As well as the level map itself, we're also going to have to alter our collision array. So remember, the black tile in the collision array represented a tile you can move through, then we had red for solid, and finally this green is going to be our semi-solid platform tile. Just as we did with the red solid tiles, I'm going to just paste it in the bits I want to have the semi-solid platform tile. So remember, most of this column is going to be one you can move through, and it's only at the very top that you're going to get stopped. So if you've played Chakan the Forever Man before, you know how the column works. It mostly is in the background, but you have a bit that it does have collision. And with these little platforms here, obviously I'm going to make these green too. So all of these in green you'll be able to jump up through, but on the way down it should catch you if we do the code right. And this is what the collision array should look like when we're finished. I've already demonstrated these a couple of times in previous lessons, how to take your code and your map from 16 tile and import it into SGDK, so I won't cover that now. So this is the end result after putting our new map in and our new collision array too. So you can see I can jump at the collision tiles, the platform tiles, the semi-solid ones, the new ones we put in, but obviously since we haven't changed any of the code yet, it's having no effect. It's just acting like a usual normal free tile that we can just move through as we want. If we take a look at our actual code, you can see the array's already been changed. So we've got these twos where the semi-solid platforms are. So what we need to do now is we need to create a new define, and we need to create a define for the platform tile. Now obviously that's going to be hashtag define platform underscore tile, and we're going to make it a number 2. With that done, we're going to scoot towards the bottom of our main.c, right near the bottom of the collision function code. What we need to do now is to simply take the code that deals with if the player's feet land on a solid tile, and we're going to copy and paste that just below, and we're going to repurpose it for our platform tile. So make sure you change all these solid tiles in this little bit of code to platform tile instead. If you now save and compile your code, you should get this result. So we are getting some collision now on the semi-solid platform tiles, but you can see that it's kind of jumping through and it's getting stuck at the very top, so it's kind of halting our upward momentum. It just, as soon as we go through the tile, it's making us stick to the very top of the platform tile. And that's because obviously we haven't got any head collision. The head collision in our code only works for the solid platform tiles, and of course we want it to stay that way because the platform tile shouldn't have any head collision. But what we need to do is we need to allow the player sprite to go up and only catch them on the way down. We could do a similar solution to how we fixed our little jumping in midair problem, where we just checked whether the velocity was heading upwards or not, but I seem to recall that can cause some bugs in certain circumstances when dealing with these platform tiles, so we're going to take a different approach. That different approach is going to involve creating a new variable at the top of our collision function code, and we're going to call it previous player y, and we're going to make that equal to the current player y. And of course this is before we start to add the gravity and other y velocity to the player. We are then going to return to our platform collision code, and we're going to add another condition to see whether the player gets stopped or not. Before we add this extra condition though, we first need to add some brackets around whether the tile collision type is of the bottom left or bottom right, whether either of these two are a platform tile. This makes it so that either of these two have to be true, one or the other, and also our new condition has to be true as well, and only then will there be a collision on this tile. That check is going to be to see whether the player Y on the previous turn is higher or lower than the Y on the current turn after adding the gravity and so on, because obviously if the player was higher on the map last time, then this time it means they're falling down. So in that circumstance, we can do the collision. So we're going to do the two ands as usual, and we're going to do player Y if that's greater than previous player Y. Because remember, the further down we go, the higher the Y value becomes, because the map begins at 0 at the very top. That being the case, if the player is falling down, it means that the current player Y value is going to be numerically greater than the previous Y value. If we take a quick look at our updated ROM, you can see that our little problem before is now fixed, so the player can jump up through the platform tiles and it's going to catch them on the way down. However, there's a small thing that we might want to change. It's not necessarily a bug, it depends on how you want your game to work. So as the player jumps up and down next to the two platform ones, you can see the top platform, he only reaches maybe into the bottom of the platform tile, but as soon as the feet touch the bottom and he starts to go down, he gets pushed up to the very top of that platform tile. Now this isn't necessarily a bug, it's just how the system works at the moment, but since it's quite a thick platform tile, you wouldn't necessarily want him to, if he reaches the very bottom, to get pushed all the way up again. You might want to have it so that he has to reach maybe at least from a few pixels from the top of the platform tile before he really gets pushed up. Otherwise, you probably want him to just fall back down again instead. I'll slowly demonstrate this in Sprite. So if the player jumps up, his jump only reaches this much. But of course, as long as the feet, the bottom, reaches any point in the platform, on the way down is going to get pushed up to the very top of that platform. What we need to do is add some extra code that checks once the feet are in the platform and the player's momentum is going downwards, to do another check to see whether it's within a few pixels of the top, and that number of pixels is decided by the game designer. If you closely observe this original Castlevania Symphony of the Night on the PlayStation and these platform tiles here, you can see that first of all they're a bit smaller, they're 8x8 tiles instead, and the player, if his feet reaches the very bottom, the Alucard won't necessarily get pushed up. It's only when the feet reach within maybe I think 3 or 4 pixels of the top of the platform tile that Alucard gets pushed up. So you can see the same effect happening, but it's just not as, it's a bit more subtle, it's not so exaggerated. Now let's start adding some code so we can implement this effect in our little demo. Before I do so, let me change this to else if, because I forgot to do this earlier, so we can have if the bottom is a solid, or else if the top is a solid, else if the bottom is a platform tile. So I think we can get away with that and use fewer CPU cycles as a result. Recall that our blocked coordinate variable here is just the position of the player if they were to be at the very top of the platform. So this is what they get pushed to if they have a collision with the platform. So we already have the coordinates of the player at the top of the platform, and we just need to do a check that if it's just maybe 2, 3 or 4 pixels below this, that's when they get pushed up and not otherwise. This is an integer variable and our player Y variable is a fixed 32. So what we want to do first of all is create an extra variable here to record the player Y as an integer rather than as a fixed 32. With that complete, we can now create an if statement to do the check to see if whether it's in a certain number of pixels of the top of the platform, and if it is, then we can do, and only then will we do the actual collision code. Be careful here and make sure that the blocked coordinate calculation is taking place outside, it's taking place before we do this if statement. Now we need to move that collision code to within the curly brackets of the if statement, and of course after that we need to put something within the regular brackets of the if statement just to set the condition, and then if that condition is true then the stuff within the curly brackets will take place. What we are going to write here is to check whether the player Y, the integer of that, whether it's less than the block coordinate plus whatever leeway we want to give it. So how many pixels below the top of the platform we want the collision to take effect and the push up effect to take place. So I'm going to choose 8 here. So if you look at the ROM now, we can see that the player, their feet is not reaching within 8 pixels of the top, maybe it's within like 13 pixels from the top. So the player doesn't actually get pushed up by that second platform, but when he falls down he does get caught by the platform below it. If I make some changes for the jumping velocity, for example making the jumping more forceful, it means the player's going to jump higher. And if we then save compile and look at the ROM again, I think the player should jump high enough to reach within 8 pixels of that tile of the top of that platform, so he will get pushed up in that circumstance. So it's working much like we saw in Castlevania Symphony of the Night now. And of course feel free to experiment with different gravity, different jumping speeds, and also a different number of pixels from the top of the platform before you get the push up effect. While the code we wrote does seem very successful, if we play around a bit more we'll notice a big bug that we need to fix. We need to work out while we are falling through these two platforms, so we can jump up through them okay, but when we fall down from a high height, it goes straight through them to the solid platform. This is related to the problem we talked about a couple of lessons ago when we added a terminal velocity. Remember that our collision tiles are 16 by 16, we want to make sure that the terminal velocity, the maximum velocity they can fall down, would be less than 16, otherwise there's always a danger of the player actually moving past any collision tile without any the collision code taking effect. With what we've done here with the platform collision tile, we've got it as a 16 by 16 tile, but we've added the extra thing that if it has to be, the player feet have to be within 5 pixels of the top of the platform tile, otherwise there will be no collision effect. As you can see me demonstrating here in a sprite, if we fall down and if the downward velocity is greater than the number of pixels we set from the top of the platform tile before the collision takes effect, it's possible they could fall, although the feet land within the platform tile, it's beyond the number of pixels from the top that we set, and if that's the case, of course the collision effect won't be executed, the collision code won't be executed, and it will simply fall straight through that tile, and the same with the second tile too. And of course eventually it'll meet the solid tile, and the solid tile that doesn't have such extra conditions for the collision, so it wouldn't happen. One solution would be simply to make the terminal velocity to less than the number of pixels from the top of the platform that we set, but of course here we've just set it to 5. The terminal velocity at the moment is 13. If we set the terminal velocity to 5, it will fall very slowly, it'll be very floaty. So I don't think that's a very good solution, so we need to think of something else. And that something else is going to be to add an exception to the code we wrote before. So remember we said that the player had to be within 5 pixels of the top of the platform tile before the actual collision code for the platform will take effect. But we want to make an exception to this. We're going to say or, and then we're going to add an exception that says that if the player is actually, if they start off above the platform, then we ignore that one. We let the collision code play out as normal. And remember, our block coordinates are the coordinates of the very top of the platform. So if the previous player Y, if that is above the blocked coordinate, then we allow the collision. That means that the player is actually falling from above, and in that case we'll let the usual collision take place. Whenever you're making any kind of logical comparison, always bear in mind the data type of the two things you're comparing. So this previous player Y, it's actually a fixed 32 number, whereas the block coord is an integer. So we need to do the conversion for previous player Y before we can compare them. Now sometimes when I put the fixed 32 to int within the if statement, it seems to have some stranger behaviors, so I normally prefer to create a separate variable, and we're going to call this previous player Y int for the integer version of that previous player Y, and then I'm going to simply paste that in instead of doing the fixed 32 to int within the if statement. I think most of the time it's fine, but I seem to recall I had a couple of problems with that in the past. Come to think of it, I think those brackets I put around that first part is a bit superfluous. I think I can do without those, so it makes it look a bit neater that way. Now let's save and compile and see if it works. And it looks like we've fixed our little problem. Before we move on, I just want to make a slight change to our code here. So at the moment we've got, in the if statement, we're going to add 5 to the block coord, but that's a bit lazy in a way, because if you come back to that code months later, maybe you'll forget what that +5 means, what that 5 number means. So I'm just going to create an extra variable. I'm going to give it a very verbose name, as you know, how far below platform before push up, and I'm going to make that 5. Then I'm going to put that variable within the if statement, so that just so it's a bit more clear what that 5 means, rather than it's usually not a good idea just to put hard-coded numbers into your code, because you could forget about them when you look into it at some point in the future. It's generally best to use variables instead. Before we go, I just want to add one more thing, and that is you often notice in platform games when you have these kind of semi-solid platforms, if as a player you hold the D-pad down and press the jump button, you normally fall down through the platform. So I just want to add that bit of control here. In our code we have two functions that deal with the controls. We have the handle input function, which is of course for any continuous control, so that's good for D-pads. You can hold the direction of the D-pad down and you don't have to keep pressing it, you just hold it down and it keeps moving. And then we have the joy event, which is a single instance of a push, so if you press the C button then you want to jump again, you have to let go and press C again. You can't just keep holding the C button down. If I were to put the downward D-pad control in this function here, the joy event, it will mean that you would have to press the D-pad down and the jump button at precisely the same time within the same frame, otherwise it won't take effect, and that's a little bit too precise. So what I'm going to do is I'm going to create a boolean to see whether the D-pad is down or not, and then I'm going to put that into the handle input function so that you can keep hold of the D-pad button down and then you can just press C once and then you'll fall through down the platform. And to do that we're going to have to create some if-else statements, just as we did with the left and right movement of the D-pad. Now back in our joy event function we can add another if statement. So first we're going to see whether the C button is being pushed, so we can do change and state and button C, and then we're going to add another condition to see whether the D-pad has been pushed down or not by using that boolean we just created. Let's go up to the top and create yet another boolean. This time we're going to record whether the down and C was successfully pressed, and if it is we're going to create this boolean called fall through platform. So we're going to set it to false here, but within, if the player does press the D-pad down and C at the same time, then the fall through platform will be true. I'm also going to turn this second if statement to an else if statement. Now we might need to change this later on, so I can see that it could potentially cause some problems in the future, but for our purposes here it should be fine for now. Before we save and compile we need to make some changes to the collision code in our collision function. So we've got here dealing with the platform collision. So first of all, tile, collision type bottom left and bottom right has to be a platform tile. Either one of these have to be true. Then plus player Y has to be greater than previous player Y, and we need to add one more condition. So we're gonna have to make sure that the fall through platform is set to false, and to do that we just add an exclamation mark at the beginning of fall through platform. So we need to make sure that's false too, and then if we save and compile we should see the result. So if I jump up here then press down and jump, there we go, we fell through the platform, but of course the problem is we fell through the second platform too, and if I now try and jump we're falling through all the platforms. So there's obviously a problem in our code, and that's because we haven't yet put in a piece of code to change the fall through platform back to false again. What we want to do is set a timer so that it waits until the player's feet has completely fallen through the 16 pixel platform, and at that point it sets it back to false, so it's ready to catch on to any other platforms again. Let's create a couple of 8-bit numbers to set up the timer for us. So first of all we're going to create one, and it's going to be called fall through platform timer, and we're going to make it equal to 0, and this is the counter. This is what we're going to count up from. Next we have to create another number to determine how long we want to count before we set the fall through platform boolean back to false, and we'll call this the max fall through platform time. Now how much do we need to set this to? So you have to think that gravity is adding 0.8 to the velocity every time, so player's going to be at 0.8 in the first frame after falling, and then we're going to add 1.6 to that, and then 2.4 to that, and so on and so on. So it's actually going to be a lot quicker than you think. And come to think of it, I don't think we even need to clear the actual 16 pixels of the platform. It just needs to clear the offset we created. Remember, it's 5 pixels below the top because the previous Y value of the player won't be less than the current Y value because they're starting off on the platform. So long as it is enough time to pass through that how many pixels from the top of the platform thing we set earlier, then it should be fine. So I will set that to 4 for now, and then hopefully that will be enough time and not too much, it'll be just right. And in the collision function is where we're going to put the code to reset, to do the counter, to iterate the counter, and also to reset it back to 0 and change fall through platform back to false once the timer is counted up to the max value that we just set. So if the fall through platform is set to true, i.e. if the player has pressed down and jump, then we are going to start to iterate the counter. We're going to start the count, and then we're going to check that once the count actually gets to a certain value, to the maximum value, at that point it's going to be reset to 0, the count is going to be reset to 0 for next time, and the fall through platform is going to be set to false. So remember, adding plus plus like this means to add 1 to that value, so we're adding 1 to fall through platform timer each time, and then we're going to do a check. So if the fall through platform timer is greater than or equal to the maximum amount of time we set, then we're going to, as I said, set the fall through platform, the boolean, to false, and we're also going to reset the fall through platform timer back to 0. The reason I set the condition to be greater than or equal to rather than is equal to is just in case for some weird reason it skips one, adds 2 one time, just to make sure it catches that condition. It's very unlikely, but just to be better safe than sorry. Taking a look at our new ROM now, you can see that if I press down and C, we're dropping through the platform, but we're getting caught by the next platform, and we're not getting stuck on a single platform. So it looks like we got the timer right and the code's functioning quite well now. I'll post the source code for the lesson on my Patreon as usual, and for everyone else, just make sure you copy everything very carefully and feel free to experiment with everything too, because although we've done quite a lot here, the more you play about with the level collision and the controls, the more you'll notice that there are certain circumstances that can produce unexpected bugs, and just expect to keep on adjusting this again and again and again as you develop your game. Okay, so I think that just about wraps things up for this video. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.